Greetings everyone. Today I will present to you about the classification of organic compounds. By the end of this lesson, you will be able to define the term functional group and classify organic compounds based on their functional group. Organic compounds are generally classified based on their functional group. What are the functional groups and what groups of organic compounds are known on the basis of this classification? The functional group is the part of a molecule or compound that determines the physical and chemical property of that molecule or a compound. Based on the functional groups, they possess the most common classification of organic compounds, including alkanes, alkenes, alkynes, aromatics, alcohols, aldehydes, ketones, carboxylic acids, and esters. The common functional group of some organic compounds, the functional group of alkane is this one, carbon-carbon single bond, and the general structure of alkanes is RCH2CH3. R is an alkyl group, or it represents what the carbon atom bonded with what hydrogen. Example, propane, H2C, single CH2CH3, and alkene has a functional group of carbon to carbon double bond. The general formula or the general structure of alkenes is RCH double bond with CH2. The good example of ethene is the good example of alkene is ethene. Alkyne has a carbon-carbon triple bond, functional group of carbon-carbon triple bond. The general structure of alkyne is RC triple bond CR. A good example of alkyne is ethyne. Aromatic hydrocarbons. The simplest form of aromatic hydrocarbon is benzene. All aromatic hydrocarbons contain at least one benzene ring. Therefore, the functional group of aromatic hydrocarbon is this one. Six-sided is just like what six-sided polygon, and there is what alternative double bond within what the structure. The general structure are and also what at least one benzene structure here. Toluene is a good example of what aromatic hydrocarbon. Alcohols has functional group of what OH. It is hydroxyl group. Okay, we can differentiate alcohols from other compounds by this hydroxyl group. The R general structure for alcohols is R bonded with hydroxyl group. R represents what is an alkyl group or carbon atom. A good example of alcohol is ethanol, which is found in all alcoholic beverages. And aldehydes, functional group of aldehydes is CHO, carbon or carbon bonded with double bond with what oxygen and single bond with what one hydrogen. And here there is what a carbon atom around here. Okay, the general structure represents that R CHO or R single bond with carbon, double bond with carbon, double bond with oxygen, and a single bond with what hydrogen. The good example of aldehyde is ethanol. Ketone, the functional group of ketone is carbon, C double bond with oxygen. Ketone has what one carbon to oxygen double bond, and the carbon atom bonded with what two carbon atoms in both ends. The general structure of aldehydes is RC double with oxygen R. Okay, carbon bonded with one, a double bond with what one oxygen atom, and single bond with two carbon atoms or two alkyl groups. A good example of ketone is propanol. Carboxylic acid has a functional group COOH or CO2H, or represented as this structure, carbon, double bond is oxygen, single bond is one hydroxyl group. The general formula of carboxylic acid is RCOOH, or RC, double bond is oxygen and single bond is one hydroxyl group. Good example of carboxylic acid is ethanoic acid. Ester has what COOR group, is different from what carboxylic acid. Both carboxylic acid and ester contain what, one carbon atom and two oxygen atom in the functional group. But the only difference is in carboxylic acid, there is what, one hydrogen atom at the end, but in esters, there is what, one R group, alkyl or carbon atom. Uh, the general formula or general structure of ester is RCOOR prime, but the general structure of carboxylic acid is RCOOH. A good example of ester is ethyl ethanoids. Okay, this is the end of this presentation. Thank you for watching.